Okay, let's get going on this one here. This is 514. This is video 81. As I promised, we'll talk a little bit more about the problems that the Regents cares about on this polynomial math. And one of them is finding the shaded area. That says x plus 1 there. That says x minus 2. That's a blank, smaller rectangle. And there's the larger rectangle. So most of you are cognizant of the fact that it's the large guy minus the small guy gives you the shaded guy. So it's obvious that they're trying to, that means the area, and the area. So that means they're just trying to get you to look at this stuff. We'll leave aside restrictions here, but we know that x has to be greater than 0 for this to work. And in fact, x can't be 0. X would have to be at least 1 for this to work. But I won't get too deeply into that. Later we'll talk more about it. And so what's the area of the first one? And you should be minded, if you're doing what you're being asked to do, of assignment number 5. Number 5 on assignment number 32. And there's the big guy. Whoops! Typical of me, making careless mistakes. Can't do that on these videos. It's a big disadvantage for me. The outside is 3x minus 2. So that takes care of the big guy, making sure I copy all the numbers. And then this minus the small guy, which is x plus 1 times x minus 2. Okay? So here, actually, x would be bigger than 3. I'm just looking at the interesting time. 3 or greater, I think, but we're not going to worry about that now. And that's the shaded area. So you're familiar with that from the last test, and even before that, we were doing problems like that. So the length times the width is 6x minus 4x plus 3x. Minus 2 minus, we'll keep everything in parentheses here, okay, x squared minus 2x plus 1x minus 2, and we'll give ourselves a little bit of room to do this. Put together your middle terms. I put a 1 there, I don't know why. The opposites, oops, we'll put these together, we'll put these middle terms here. Some of the weaker students might really want me to do that. And there we go. That's minus 1x minus 2. Take your opposites, and you get 6x squared minus 1x minus 2. And there are your opposites, plus 1x plus 2. Okay? And cancel, 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 cancel. So it's the area is 5x squared, a quadratic monomial. And like I said before, they have to be quadratic. It's representing the area of this. And so you might want to add this to this, and you'd end up getting the first guy over here. All right? So you could easily check these just going the opposite way around. And as I mentioned before, they work just like numbers. Just they're polynomials now. The math has changed over a little bit. Okay, so let's move on to the next one. And we got everything down there. And now we erase. And we come up to the next idea. There'll be 3 ideas here that the Regents is fond of, and they expect you to be able to do. So we'll make sure that they're on assignments and you're able to do them. This guy would go away as well. There's no need for him anymore. And there we go. And we're just drying the board off a second so we can continue with the second concept. And that's of a rectangular prism where the volume would be cubed, as you well know, or as you're supposed to well know. So we'll make a rectangular prism and connect the vertices. I think most kids are familiar with that idea. And I'll move this over just a bit so you can see that. And now I'll label the sides. I'll call this side 2x plus 1. I'll call this side x plus 2, and I'll call this side x minus 1. Okay? So again, all linear binomials to represent the sides, or better put in math, the edges. So what's the volume? Well, the volume is the length times the width times the height, which turns out to be 2x plus 1 times x plus 2 times x minus 1. So some of you might be looking at that and saying, oh my God, but it's really no big deal. I'm going to go left to right and just multiply term by term. I come up with 2x squared plus 4x plus x plus 2. And we're multiplying this times the leftover edge over here. We combine like terms, and I get 2x plus 5x plus 2 times x minus 1. You could switch these. You can do it any way that's comfortable with you. Just remember, you're going to get six terms when you do this. And we make sure I draw the arrows 1, 2, 1, 2, 1, 2. You could flip them since multiplication is a commutative property. 2 times 3 equals 3 times 2 is what I mean. But I'll just go left to right here. I'll give you some work and you contact me if it's a big deal. 2x times x, well, we're expecting that. There's 2x cubed. So the volume has to be cubic, right? So we're sort of demanding a little bit of work here. After that comes minus 2x squared. I multiply that times the negative 1. Now we go to 5x. That's 5x squared. And then we multiply it here, minus 5x. And finally, plus 2x, and there's minus 2. Okay? So 1, 2, 3, 4, 5, 6 terms. You should check yourself. You didn't make a careless mistake. And now we'll just write them over here. Let's make sure you can see that clearly. There we go. There's 2x to the third plus 3x to the second minus 3x minus 2. So it's got to be cubic. Like I said, that it's a cubic polynomial with 4 terms. And you found the volume. I'll give you a problem like that. You could do lots of takeoffs on this stuff, but they want you to be aware that with the polynomials, you can represent volume. This is the polynomial representation of the volume of this particular guy, with a restriction that, let's see, x definitely has to, we'll go to this one here, x definitely has to be bigger than 1. So if we're using only whole numbers, x would have to be bigger than or equal to 2 or greater than 2. I'm going to press these ideas because they come up big time later. Okay, so we're up to 8 minutes now, so we're in good shape. And now we have to do one more problem now that's dear to that, practicing on multiplication skills. And that, well, maybe not of course, but you won't be surprised if I tell you that's lateral surface area. Oh my God, did they fall in love with lateral surface area? Why not? Might as well. Okay, and I'll give you a problem there where we just work out. Remember, before I do this problem, that pi is just a number. It's not a magical thing. Pi plus pi is 2 pi. A lot of kids see pi and they get all flabbergasted. So you have some sort of can, cylinder, and you let r equal x minus 1, and you let h equal 2x plus 3. Just throw out some algebraic expressions there. So the question would be the lateral surface area. And those of you who are really paying attention see, it's just another rectangle. But this time, of course, we'll get pi on it. So we open it up. We open up the label. This has been explained to you many times. And the circumference is 2 pi r. But instead of r, of course, we write what? Okay? And on the other side here, we write height. And this would be your surface area all in here. Okay? So that's the deal, no big deal. And I want to do these because I need to distribute here. Monomial times a binomial. So we'll end up with 2 pi x minus 2 pi times 2x plus 3. And again, I repeat to the weaker students, pi is just a number. Remember that. Keep that in mind when I'm doing the work here. So 2 pi x times 2x is 4 pi x squared. You double check yourself to make sure you didn't make a mistake. And 2 pi times 3 is 6 pi, and the x just tags along. Now we do the inner part here, and we have minus 2, 4 pi x, putting everything together, and finally minus 6 pi. Okay? So now we see that these are like terms in the middle, or you should see that. Good, the space is good. And there we go. And that's plus 2 pi x minus 6 pi. So this is just 6 times 3.14. This is just 2 times 3.14. And this is 4 times 3.14. You should see it that way. It's a quadratic trinomial. And but because of the x's, they're all unlike terms. There's room for factoring here. We'll talk about that later. This lends itself nice to factoring, but that's all you'd be expected to do at this point. So there's the answer to that. I'll make sure on your next assignment that all 3 of these problems appear along with others. Okay? So that does it for more on multiplication. Again, we're following the problems that the Regents fell in love with. Okay.